Hey, good morning. I'm going to introduce you to chuck jaw grinding, the way it's done out in this region here. And there's some different methods, but it all kind of boils down to the same to make it work the best. And you got to load the jaws of the chuck when you grind them. And I'll get into that. But first off, you have to start at the beginning, and we'll do that right now. Okay, now number one is the interface of the back of the chuck, the locating taper, and this spindle. The chuck must fit the spindle tight, go on the same every time. And also, some don't do this, but it used to be done way in the past. They put a mark on the chuck here to index to number one pin on the spindle here. So you index the chuck the same to the spindle. The taper fits tight, but not too tight. It locates the chuck. Now, see, this chuck was damaged. This is an eBay buy. And I took the pins out, checked the taper on here, and it was loose. And I inspected it, set it up on the jig boring machine, but I could do it in a lathe. But I didn't have a lathe big enough to do it. I was just using the Monarch 10 EEs. And I refaced this, and then I recut the taper and fit it to the spindle. So this chuck, this is all new here, even though it's an old chuck. These surfaces are new because they needed to be, because they were damaged. So now the chuck goes on there square, okay? That's like number one. And these back plates are nothing to be afraid of. I'll show you here. I haven't ever made any D16, but I've made a bunch of these for the Monarch 10 EE. And this is one I made here. I can adapt different things to that spindle. And of course, when I made it so it fit tight, but not too tight. And that's number one. The chuck's got to fit. And the problems with the D-type spindle don't really happen with the L-type or threaded, okay? Just as long as they got everything square. But the D-type has that problem, and it's overlooked. And it looked to me like it was overlooked. They were trying to make this chuck run good, but it wouldn't go on the spindle right or stay the same. And they bought extra jaws and got sick of it and sold the whole kit and caboodle to me on eBay. So now I make this work. So that's number one. Okay, I will be back. Okay. We have this Cushman 8-inch direct mount. It means it doesn't have a back plate. 3-jaw chuck mounted squarely to the spindle. The interface has no slop, it's flat. That's taken care of. And this video is not on rebuilding the chuck. That's another subject. But I inspected this chuck, checked it out, took it apart, cleaned it, lubricated it, and determined that it's still got a go or two on it, and without totally rebuilding the chuck. So what I'm going to do is just touch up these jaws, okay? So I'm going to put an inspection bore in there, and we'll start inspecting it to see where we are so we know where we want to go. Okay, I'll get that going. Okay, now this is the next step for grinding the chuck jaws. We got the chuck mounted good to the spindle. The chuck is lubricated and clean. So now we're going to check out the pinions and runout. So this is number 1 pinion here, and it's marked as the master pinion right here with a V. So let's check it out here. Slightly rotate that thing, find a good spot for it. The jaws feel a little bit rough. Snug it in. Okay, let's rotate that thing, see how much runout there is. Okay, there is 1, 2, just about 3/1000 runout on the master pinion. That's pretty darn good. And you should check that a few times, but we'll go ahead and move on over to number 2. Okay. We'll move it over to number 2 here. And I start tightening it and rotate the shaft just slightly. There we go. Pull it tight. Okay, let's see where we're at with number 2. Let's see if I can get that. 1, 2, 3. Just about 3/1000 run out on number 2. That's great. That, see, this just needs a little bit of touch up. So let's try number 3 pinion. Okay. I'm just going to rotate it slightly. There we go. Let's see where we're at. Okay, that's pretty good. 1, 2, 3. So it doesn't really matter. We're getting about the same run out on all the pinions. Let's go back to number 1. That's the master one that they marked at the factory. Okay. Try that again. Oops. 1, 2, 3, 4.5/1000 that time. Let's get back over here to, there's number 3. Let's try number 3 a second time. Got some inconsistency on the master pinion. Okay. Look at that. That is 1/2 run out on number 3. Okay, let's try let's try number 2. You can't complain about that. But we got some other issues I'll show you. Okay, let's try number 2 real quick here. Uh-oh. Look at that. That is 6/1000. See, again, some inconsistency. We'll go back to number 3 again. Right about 3/1000. I've been playing with this, and I found that number 3 gives the best results. So number 3, I'm going to mark it as the master pinion. And the reason for that is because using that pinion when we grind the jaws will remove less material. And that's really important. Okay, so we got it on number 3 here. Let's play with this a little bit. Let's try it one more time here. The jaws feel rough. They need some work there. So it's not going to be real consistent. We got that. See, it's pretty consistent, this number 3, from 1/2 to 3/1000 run out. So we're going to go with number 3 pinion. Okay, now I have to move this back a little bit, and I'm going to crank this out. Got about 3/1000 run out at the nose. How much we got out here? Well, that's considerably more, but it's not as bad as I expected. Okay, we got about 5/1000. Play with that one more time. There we go. Okay, 1, 2, 3, 4, 5, 6, 7.5 That's considerable. Now let's see if we can get that out. See, it won't come out. And it takes a bit of force, see? Now, this can really damage some lathes. You don't want to hold that true with your tail center and have the bar under that kind of stress. Now this is an old, it was actually new old stock transmission counter shaft out of, I think, farm equipment, but I'm not sure what, but it's gauge accurate. This is a very accurately ground bar. Might as well have been made by Taft Pierce. So that's quite a bit. Okay, now we're going to have a look at something else here. And I've showed this before. Okay, now I'm going to rotate the bar until it just grabs, right? I can't turn it anymore. Okay, now look at this. It's got, the jaws are grabbing less at the front. But the master jaws are actually grabbing right now. But these are splayed away a little bit. But as you tighten it, it will quit doing that, you know. But that's a sign of wear. So what we're going to do is we're going to load and grind these jaws to eliminate that. In fact, it's ideal if the jaws slightly grab at the front here, because the way they are like this, they tend to want to spit small parts out or thin parts, you know, wedge them out. We want the chuck, if anything, to hold it in rather than spit it out. Okay, now I will be back. Looks like that belt will stay on there. What do you think? Maybe I gotta adjust it a little better. Well, this is the equipment here for grinding. Yeah, I'll tighten that up a little bit. Now this has a 1/2-inch threaded arbor. I have a pulley on here and a spacer washer. Now I can put this adapter on this. Of course, I fabricated this all myself. You can't buy anything like this. I call this the Boy Howdy model. Let's get that on there. Okay, so I got that on there. a point you can grind with, but I'd like to have something larger for this larger hole chuck here than little tiny chucks. So what I'll do, see if I can get that off. And what I did, I like to use things I have available. So this is like a Sioux valve seat grinding wheel. So I made on this Axelson, and this is a funny thread, it's 0.675 by 16. It's like 50 thousandths bigger than a 5/8 coarse thread. So it's proprietary thread. So on this Axelson, I made an adapter that'll fit onto this 1/2-inch arbor. If I don't drop it, oh, get it in the camera. There we go. Okay, now I can use a little bit bigger grinding wheel. That'll more fit that hole, see? And I have an abundant supply of Sioux valve seat grinder wheels. I have the entire system. So I'm going to true this wheel up, just dress it a little bit by hand. And it doesn't need to be anything fancy. And I like it kind of narrow. And I'm going to touch up these jaws. See? I don't know if you can see the wear on it. You see that? Yeah, so this is the equipment here. I fabricated this. This is 2-inch plate. I got angular contact bearings in this spindle housing here. It's running about 10,000, I believe, with this pulley setup. Okay, quite heavy, half horse high-speed motor. Okay, so I will get even more set up here, and to that all-important loading the jaws. Now, why do you have to load the jaws? It's because there's slop in them, a little play, you know? A little bit of rock. Some chucks are tighter than the others in the jaw slots. There's no noticeable, appreciable wear on the jaw slots on this chuck. So it's just the way these things splay out. It's a natural occurrence, and there's nothing you can do about it except not use the chuck at all. So we're going to load the jaws, and that's where this device comes in. There is many ways to do that. Now, if you look at this, and this is the way Travers used to sell them in some other places, they take a plate or a piece of nylon and drill a hole for the center hole of your chuck, and then have holes in the plate that take the place of these. But I think this is quite a bit better. So I'm going to install this onto the chuck. Let's see if I can get that on there. Just about like that. And where did that go? Hold on. We will get that chuck, John. Okay, I'm going to start tightening this fixture by opening the jaws. Get it more in place. I kind of hooked on something there. Let's see if I can get that on there. I was going the wrong way. I go, what's wrong? Okay, here we go. I'm going to start moving that in. Now there's a couple things I want you to notice what's going on here. Like the location of this fixture. Let's get that on there. Got to jiggle it a little bit. You got to worry it on. Okay. So I just kind of basically got this thing on there. Okay, let's have a look at it from the front. See how that is? And it lets the jaws protrude just a little bit past the cutouts in the ring, okay? And it doesn't matter if the grinder bites into the rings. It just doesn't matter. So we're going to run the grinding wheel in there. Remove that. And we'll get it over. And I think this wheel is just about right. Not quite. It's going to hit a little bit at the top. I might have to, well, I have to adjust the fixture a little bit or put a slightly smaller wheel in here. Okay? It's good to check it out before you run it in there spinning. Might have to. We'll just see how it is. No, I don't think so, because I think the jaws are protruding a little bit. So I'll get this adjusted. So the way you want it is the jaws just entering the center hole. And that's how you want them ground. Okay, now notice how this is holding the jaws. It's holding the jaws more at the front. And that's beneficial because it holds the jaws back. And then the back of the jaws tend to rock inward and get ground more than the tips, see? So when you're done, the chuck will be restored grabbing more at the tips, okay? It's grabbing more at the back now, wanting to spit parts out. So you got a little bit of control on how much taper, I guess, you allow the jaws to set themselves at by how much tension you put on this. So the more tension, to a point, the more the back of the jaws will protrude in, a slight amount, right? Because they're not held by this ring. So if you put something back into the master jaws and grab there, then it's going to tend to allow the jaws to rock in more towards the hole and have more of that condition. And I can see, I don't know if you can, but you can see that the wear is kind of made it a little wider here on the jaw face, then a little bit in towards the master jaw. I don't know if you can see that or not. But I'm going to put ink on these, and then I'm going to get this set up and grind it, okay? And I want you to see how that holds. Now, another method that works, and it's been talked about, I guess, over the years, is drilling holes in the tips of the jaws and then grabbing a ring. And that works. That works. I know a guy that did that, and it works. And you have to get through the hardness on the jaws, but there's good drill bits. You can do it that way. And it also grabs the jaws at the tips, allowing the back to rock in. The jaw faces a little, just slightly. And they get ground slightly a little more. and the tips here a little less, and then it makes it so it grabs parts and more pulls them into the chuck instead of pushing them away like it is now. Okay, I hope I made that clear. All right, so I've got a few more preliminaries to do, and I will be back and grind these jaws after I take Chloe for a walk. So I'll probably load this video and do that a little bit later. This is the preliminary setup. Let's get back and look at it. To grind chuck jaws. Now, this is a really necessary thing in the business I had. The chuck jaws just absolutely had to run true. I had to grab all kinds of parts of every matter and for repair or whatever, and modification often. And I want those parts to be grabbed true and quick. And that's why I did this, and other people do too. Making soft jaws is one approach, but I just don't have time for that. I just want a chuck to run like a new one. So that's what I do here. If you don't want to do this, then you just make all the soft jaws you want. Okay, I will be back.